We continue Unit 14, Graphing Rational Functions, by looking at horizontal asymptotes. Here we have the graph of the function x plus 3 divided by x plus 2. Do you see a horizontal asymptote? The horizontal asymptote is at y equals 1. We can also look at the equation to determine the horizontal asymptote. If the numerator and denominator have no common factors, then the graph of f of x has at most one horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, then the line y equals 0 is the horizontal asymptote. If the degree of the numerator is equal to the degree of the denominator, then the line is y equals a divided by b, and that's the horizontal asymptote. A is the coefficient of the highest powered value of the numerator, and b is the coefficient of the highest powered variable of the denominator. So it's leading coefficient, or LC, divided by leading coefficient, and that's equal to y. If the degree of the numerator is greater than the degree of the denominator, then the graph has no horizontal asymptote. These will have end behavior that slants, known as slant or oblique asymptote. So if the degree of the numerator is less than the degree of the denominator, y is equal to 0. If the degree of the numerator is equal to the degree of the denominator, in other words, if the exponents match, we use the numbers in front. And if the degree of the numerator is greater than the degree in the denominator, there's no horizontal asymptote. Let's go back to the graph we just looked at. We could see by looking at the graph that the horizontal asymptote was at y equals 1. But let's look at the equation. The degree of the highest powered variable is a 1 in the numerator, and the degree of the highest powered variable in the denominator is also a 1. So we're looking at the degree in the numerator first. The degree in the numerator is 1. The degree in the denominator is 1. 1 is equal to 1. When the degree of the numerator is equal to the degree of the denominator, then y is equal to that leading coefficient divided by leading coefficient. So in this case, y is equal to 1 over 1. So the horizontal asymptote is y equals 1. Another thing to note is the horizontal asymptote describes the end behavior only, what happens at the far left or far right of the graph, not the middle. Also remember that the degree is the highest power of x. Find the horizontal asymptotes of each of the following. So let's look at the degree of the numerator first. The highest power of x in the numerator is a 3. In the denominator, the highest power of x is 2. 3 is greater than 2. When the degree of the numerator is greater than the degree of the denominator, then the graph has no horizontal asymptote. Let's look at this next example. The highest power of x in the numerator is a 1. The highest power of x in the denominator is also a 1. So the degree of the numerator is equal to the degree in the denominator. When the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is leading coefficient divided by leading coefficient. So the leading coefficient in the top is a 2. The leading coefficient in the denominator is a 1. So y is equal to 2 divided by 1, which is 2. In the next problem, I'm looking for horizontal asymptote. So again, we're looking at the degree in the numerator. In this case, it's a 1. and the highest degree in the denominator. In this case, it is a 2. 1 is less than 2. When the degree of the numerator is less than the denominator, then the horizontal asymptote is y equals 0. In the next problem, we see 3 divided by x minus 5. We do not have a variable in the numerator. In this case, that degree would have been 0. The degree of the numerator is 0. The degree in the denominator is 1. 0 is less than 1. Again, when the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0. Let's identify the horizontal and vertical asymptotes for each of the rational functions below. The horizontal asymptote is at y equals 3. The vertical asymptote is hard to tell. So at this point, there's not enough graph to tell if x equals negative 3 or x equals negative 2. So I'm just going to write them both down, because this one later on could possibly come down here, or this one could possibly come up here. We don't know. Not enough information. On the horizontal asymptote, on this particular problem, there is not a line that the graph is flattening out towards on the end behavior. This one has a slant asymptote, so there's no horizontal asymptote. The end behavior slants. The vertical asymptote is at x equals negative 1. In the next problem, the horizontal asymptote is at y equals 0, and the vertical asymptote is at x equals negative 3. In the last problem, the horizontal asymptote is at y equals 0. And the vertical asymptotes are at x equals negative 2 and x equals 2. Keep in mind that the graph can cross a horizontal asymptote, because the horizontal asymptote only determines the end behavior, what's happening at the end.